This particular example, this planar brake is polished up and seems to have preferential alignment or lineation that I'm going to measure. The angle that's going to allow me to measure is called the gamma angle, and that's going to allow me to, using my calculations, once I know my dip and azimuth of the drill hole, I can work out the plunge and plumb direction of that linear feature. Now, it may not be that easy to see on the camera, but there is a bit of a polished up surface where I think there's a bit of a preferred slicken line type lineation going on. So I'm going to mark the center of the core and make sure that my reference trace of that lineation goes through the center of the core. Once again, as per the beta angle, I need to measure the gamma angle relative to the lower part of the drill hole on that particular plane. There, I'm going to mark that as my gamma reference. So basically, what our gamma angle is the angle between the beta reference and the gamma reference. And you can measure that in a variety of ways, but the quickest way to do it is to simply use your protractor again and just measure it in a clockwise direction, and that's going to give you approximately an angle of, say, 54 degrees in that example. Or if you wanted to measure it even more accurately, you could get a protractor and measure that angle, but it's going to be plus or minus a degree or so, so that's suitable in this case. So here's an example where this particular segment of core, the top part of the core, looking down hole, it's a little bit irregular, it's not particularly reliable, I'm not that confident about what I'm seeing, but the bottom part of the hole has a nice planar feature to measure, along with that polished slicken line that I think I'm seeing there. So same process, I'm looking at the ellipse. There's the short axis of the ellipse, the long axis of the ellipse. I'm interested in the long axis of the ellipse, so the maximum apical trace is going through the center of the core along that direction. Now, looking down the hole, I need to figure out what is the lower part of the drill hole. Now, I'm holding the lower part of the bottom of the hole using the bottom hole reference line, so obviously this end is the lower part of the hole and that's the upper part of the hole. So to measure my beta angle from, it's the lower part of the hole. So that there is going to be my beta angle. Gamma, simply taking note of the middle of the core again and just tracing that lineation through the center of the core, and then deciding, is this the lower part of the hole or is this the lower part of the hole? And as explained, this example is the lower part of the hole, so that is my gamma reference that I am going to mark to make my life a bit easier. So there's your gamma. So measuring the beta angle, we're measuring clockwise from the bottom of the hole reference line, so that's clockwise that way, or obviously anti-clockwise in that direction, which I'll show. And the gamma angle we need to record is the difference between the beta reference in a clockwise direction to the gamma reference. So to measure our beta angle, I'm making sure that my strip, if that's what I'm using, is pointing in the downhole direction. So the arrow is in this direction downhole, so that's in the correct orientation. So in this example, the beta angle is in the order of 332 degrees. The gamma angle is obviously the difference between this line and this line. So you could use a protractor to measure that angle to get an accurate gamma angle, or usually I'm comfortable just to use the strips and measure, once again pointing in a downhole direction, putting the 0 this time not on the bottom of hole orientation reference but on the beta reference, and measuring clockwise giving me a gamma angle that I record as about 57 degrees.